MacMaths, MacMaths, let's do some maths today. Statistics. So we're still on chapter 1, last little bit. I just thought I'd talk for just 5 minutes on the large data sets. Okay. So just some things that you need to know about large data sets. So Edexcel supply a large database for this chapter that you may get asked questions about. They may give you the whole database or sections of it on the exam. And the one that they use is one from the Met Office in 1987, so about the weather and around the world and so on, with lots of things on. So the reason that they provide that one is because they see it as typical of an information database, one that you go and get a job or where you work in some industry and they're collecting lots of sort of data from around the world. It would be a typical sort of working database, okay? And so it's a bit more real life attached to the maths that we do. And I just want to look at things. There are things specific to it, with it being a weather one, that you need to know and learn. So you need to go over it and learn it, and I did. Obviously for this particular chapter, there's a few things that I didn't know, I'm just going to talk you through a few things that you need to be aware of, because you will get questioned about them. Okay, so first of all, temperature, degrees C. Okay, so you're going to get that if it's about the weather around the world, different cities, different times, and so on. Okay, so you know about that. You know that rainfall is always measured in millimeters. Hours of sunshine, it's always like 1 hour, 2 hour. You know what you would typically get. These are average hours of sunshine per day or whatever. So this would be in hours. Wind speed is in knots. If you don't know what knots are like miles per hour. They're almost similar to miles per hour, but a knot is a bit more. And 1 knot is it's a nautical distance. I think it's to do with, there's a straight line, but because of the curvature of the Earth, this might not be true, but that's what I always understood it. Because of the curvature of the Earth, a mile horizontally is actually a little bit further because of the curvature of the Earth. Okay, that might not be true, but that's what I thought when I was taught or heard somewhere when I was young. So, but anyway, regardless of that, a knot is a bit more than a mile. So wind speed in knots, if it's 30 knots, it's a bit more. That's a bit more. It's in miles per hour, it would be a bit more. Okay. But very similar. Humidity is in percentage. So when the air holds the most water it can, and you've been in those, you may have been to the tropics where it's sort of sticky and it feels, but summer days when it feels very humid in the air, then when the air is holding its maximum amount, that's called 100%. Doesn't mean it's like being underwater, but it's 100%. So anything above, and I just read this from the book, anything above 95%. If humidity was 95%, it would feel hot and steamy, like you're in a tropical jungle. But anything above that, it creates like precipitation and rain and so on. Okay, so humidity is a percentage. Okay. If you went to the Arctic or the Antarctic or something like that, the humidity there would be 0%, because it's too cold. That the water vapor, then any water molecules would coagulate and freeze into ice. So that those are places, the very north and south of the planet, are known to be very dry. And like you climb up to the top of the Andes or whatever, it's very dry up there. Deserts would have 0% humidity. Okay. Visibility, I looked this up only from the book. It's got it in decimeters, so I think that must mean 10 meters. So if they say the visibility is 8 decimeters, it means you can see 80 meters. A foggy day it would be less. A bright clear day with no air pollution, it would be more. Air pressure is in hectopascals. It's just a number. Okay. Generally, high pressure in summer is a good thing. It means good weather is on its way. High pressure in winter, it usually means no clouds. It means it's no cloud cover that actually keeps the planet warmer in winter. So high pressure in the winter usually means colder weather, you know, sunny but cold, those nice days that you get when you're out skiing. Okay. And cloud cover, here's one for you to learn that I learned from this book, is in octas. Okay, and it's that, it's spelled that way, this here, this oct bit, think of oct as in October. Not actually, no, don't think of it as in October, because that's a bad example. We could talk about that, but it's a history lesson, is it? But as in what oct means, octagon, it means 8. And octas, but spelled with a K, is about cloud cover, and it's the 8, how many eighths of the, when you look up at the sky, how many eighths. So we divide the sky into eighths, and so all the sky that you can sort of see above you, divide it into eighths, and how many of those eighths would be covered in cloud. That's how they measure sort of cloud cover. So if it was completely covered in cloud, it would have an octas, a value of 8, wouldn't it? Okay, and it would have an octas value of 0 if there was no cloud. Okay, so it's in the amount of eighths. Okay, which leads me nicely on to this database now, and that is that what you have to be aware of with a real database, there's going to be human error and anomalies, because somebody has put that information into the database. So you have to be aware when you're collecting and doing averages, you have to be aware of the chance of being anomalies, and whether you choose to ignore those and take another data piece, or, you know, human errors. So for instance, if you were working out in a month the average, and this is a good example, and it actually sort of uses one in one of the questions. If you were working out the mean cloud cover in a month, so you've got 30 days perhaps, and you've got a value in each one of those slots for the cloud cover, and it's a number like 1 to 8, and you add them all up and divide by 30 to get the average for that particular month. But say one of those values was, instead of being 1 to 8, was outside of that range. So say it was, you know, 10 or something like that. Well, of course, if the octas was 10, then that value must have been a human error, because the values only go up to 8, and you would ignore that because you would know it was an error. So you would have to do the average based on 29 days then, wouldn't you, if you wanted it in a particular month? Okay, you'd have to do it on 29 days rather than the 30 days for the month. Okay, because you would know that one of the numbers was wrong. Okay, so you have to be aware of human error. Okay, so human error may be sort of linked to this, you know, missing data as well, because they forgot to put someone in. It may not be, I'll talk about that in a second. But always look at the data, look for human error and anomalies. And when you see an anomaly, something that doesn't really fit the trend of that, you've got to question yourself, you know, was that right? Okay, so for instance, if you're, say it has a very northern town like Oslo, you've got temperatures at Oslo and it's a winter, and those temperatures are the average high daily temperatures like 1 degree, 3 degrees, 2 degrees, and so on. You know, and then suddenly, you know, one of those temperatures is 18 degrees. Well, 18 degrees is a realistic temperature, isn't it? That's okay, but it's not a realistic temperature for Oslo in the middle of winter, when all the other temperatures every other day are always between sort of 1 and 2 or 3 degrees. Okay, so you've got to look over it with a discerning eye. Okay, so human error and anomalies. And there's a phrase I want to use is that, and you will need to know this, okay, it's called cleaning the data. Cleaning the data. So when you're dealing with a real database, you may have to clean the data. And what that means is you remove bits of data that you think or you can show are anomalies or human error. Okay, so getting rid of those. All right. Okay, so be aware of that with this data. I want to draw your attention to this word trace, because that's going to come up. So you might find that when you're doing data, it says find the mean daily rainfall, and it may say on this particular day there's 0 rainfall, and that's, so you're adding up these numbers, and there's 5 millimeters another day, and 15 millimeters another day, and 0 meters another, and then you come across this here, TR, and that means a trace. It means a tiny bit. So there's a little bit of drizzle. So the person has recorded that there was some rain, but not enough to register. Well, if you're working out the mean rainfall, you treat where someone has put in a trace to indicate that, yeah, there was a bit of drizzle, but you treat the word trace as 0, okay, for calculations purpose, okay? So whether whatever it was a trace of, you treat that as 0, okay? So it's the same in terms of doing calculations as the number 0, a tiny, tiny amount, okay? And missing data. Okay, so if you want to do an average based on 30 bits of data and you go through, just check. If you actually want 30 bits of data, just check that you've got all 30 bits of data. So you may have to add on another one if there's one line where some data is missing. And you get those in real databases, missing data. It may be human error, but it may not be human error. Okay, it may be that the weather was so bad that the weather person could not get to the weather station to record the wind speed. It was dangerous, so they stayed at home. And so for that day, you know, that data wasn't recorded or so on. Or for some other, you know, unknown reason, the scientist had food poisoning that day and didn't record the data at the data station or whatever. But, you know, sometimes there's missing data. It just wasn't recorded for that day. The computers broke down and didn't record it and so on and so on. And in real life, that happens. So you may get missing data, and be aware of that. You may get a question, why is could the data be missing? Okay, it could be human error, and it could be that the computers broke down, there was a power cut. So you've got to be aware of all these things. These are real life things, and that's what statistics is. You know, they're trying to make this topic sort of real life, you know, in all its dullness. Okay, so have a go at those questions for that last bit. Be aware of what I've said. Be aware that we use trace as 0. Learn what octus is, because I had to learn that. Okay. Read the summary at the back and do the questions, and all the answers are in the back. Okay. The next section, when we do move on to chapter 2 next, then it's all going to be actually doing a bit more maths. I mean, it's not as good as mechanics, but you know, hey ho, it is what it is. All right. Okay, so I hope those lessons were useful. I doubt whether they were, but a little bit of a summary of just that chapter 1. Okay, thank you. Bye-bye.